Great. Okay, so you'll notice that in each module, there's always a little overview on what we're going to learn that day. Okay, and I haven't pointed it out to you yet, but maybe you have found it anyway. So it's kind of a summary of that module. And so we're moving on to moments in 2D space using the right-hand rule today. So I'm going to just open up overview. And it always has a heading of an introduction and heading of what you will learn. So in this module, you'll learn how to solve for moments about a point due to forces in 2D space using the right-hand rule. Okay, and then by the end of this module, you will know that. So here's some introductory stuff for moments. One, engineers use the word moment where physicists use the word torque. So from now on, we're using moment. Okay. The units of moments are force. Well, how you calculate moment is a force unit. It's force times distance. So that means it's going to have a unit of force times distance. In the English system, let me just move your photos up somewhere. In the English system, moment is just expressed by a distance first and then a force. So for example, foot pound, inch pound, foot kip. You remember what a kip is, right?
No.
What's a kip? What's a ton?
2,000 pounds.
2,000 pounds. So a kip, it has a K in it. Take a guess that it's going to be 1,000. Sure enough, one kip is 1,000 pounds. Okay.
A kilopound, someone says.
Say that again.
Someone says a kilopound.
I don't know who says that, but it's a
Asia.
kip.
Well,
Okay.
maybe
Okay.
no one says that.
Okay, mutes, everyone. Okay, in the SI system, moments are expressed force first, then distance. So example, Newton meter, kilonewton meter, millimeter. So remember that depending on whether you're in the English or the SI system, that tells you which unit you write first. Okay. We also already know that a moment is a vector, which means it has magnitude and direction. And if we have forces in the 2D space, which means they're in the XY plane, the moment, the spin is about the Z-axis, right? Everyone, we know that already? And it could be positive or negative. The magnitude of the moment, and this is what we're going to be doing today, the magnitude of the moment using the right-hand rule is calculated by the magnitude of the moment is equal to the absolute value of the force times the absolute value of the vertical distance. Let me make this bigger. So when today, we are working with right-hand rule only in 2D space. The magnitude of the moment is by calculating the absolute value of the force times the absolute value of the perpendicular distance. And the direction of the moment is with your right hand. So everybody use their right hand right now. And put your right hand, put your fingers together, make it flat. Fingers go in the direction of the force. The palm goes towards the point you're trying to find the moment about. And then once it curls, if your thumb is sticking out at you, it's positive. If it's sticking into the page, it's negative. I know some of you use your fingers in the direction of F and then F. That's fine. I just find it easier like this. Okay, so figure out whichever way works for you, but you want to get it right all the time. So again, I always put my fingers in the direction of the force. I put my palm to where the point is I'm trying to find the moment about, and my thumb tells me whether it's positive or not. So in 2D space, we're working with the XY, which is a vertical plane, and Z positive is coming out at us. If we get our thumb in the positive Z direction, it's positive. If we get our thumb in the negative Z direction, it's negative. Okay, any questions? Okay, I'm going to go back now. So remember that overview exists in every single module of mine, okay? So right here, I'm back in today's class module, and notice it says 2D moment right-hand rule in class problems. So these are the problems we're working on, okay? I first wanted to start out with something fun. We're gonna look at some videos. I guess I wasn't fast enough with my right finger. Here are the videos anyway. Okay, so let's watch this video. So this is how moments are used in engineering.
You might need to toggle a setting to share your audio.
I can't hear you.
We can't. If there's any sound in the video, I'm not getting it.
Oh, wait. Oh, of course. You can't hear the video. Is that what you were saying?
That's correct.
Of course, because I have the headphones on. Okay, ready?
Sure.
Welcome to the Grand Canyon Skywalk, an engineering marvel. We sit about 4,000 feet above the Grand Canyon floor and extend 70 feet out over the Grand Canyon. The Grand Canyon Skywalk opened in 2007. We've had about 1.5 million visitors from around the world. The idea from the Skywalk came from someone who was taking a helicopter tour of Grand Canyon West and thought it would be a great idea to have an opportunity for people to walk a glass bridge and see 4,000 feet below down to the floor of the Grand Canyon. The Grand Canyon Skywalk is an engineering marvel.
Okay, I'm going to stop it, but you get the idea. So what are we looking at? We're looking at the skywalk over the Grand Canyon. So certainly there's weight involved, right? And it's cantilevered out. So it's creating a moment. So the connection of the skywalk to the ground needs to be able to handle that moment. Otherwise, it would just flip into the Grand Canyon. So there's one engineering design where we actually are looking at a weight that's cantilevered out, including the weight of the people as well. Okay, let's go to another one. And you can watch each of these videos in full. Another one is about the Hoover Dam.
When completed in 1935, Hoover Dam was called the eighth wonder of the world. Rising 221 meters, it contains 6 million tons of concrete, enough to pave a road from New York to Los Angeles. A gigantic concrete pyramid wedged in a desolate canyon straddling the Nevada-Arizona border, 56 kilometers from Las Vegas. The reservoir created by Hoover Dam, Lake Mead, covers 620 square kilometers and has a storage capacity of over 35 trillion liters, enough to cover the entire state of New York in 30 centimeters of water. Hoover's hydroelectric power plant has 17 generators capable of producing 2 million kilowatts of electricity, enough for 1.7 million homes.
I'm going to stop for a minute. I'm going to go back to this. So you could see that in the first case, we had this skywalk that was horizontal, right? And the weight is here cantilevering and creating a moment about the connection of the skywalk to the ground. Now we're looking at a Hoover Dam where the water is going in here and it's trying to push it over. And again, the connection, the main design of it has to withstand that, that load from the water to cause it to create a moment. So in both of those situations, we're looking at, in the end, in statics, both of these are statics problems. We have to design connections here to be able to handle that moment that's created by the load. I'm going to go to the next one. Oh, let's try this. I don't know what's up, but let's go back. So these three I entitled Successful Designs, the Grand Canyon Skywalk, Successful Design, the Hoover Dam, and this is bike pedaling. And you could imagine that when you're riding a bike, you're creating a moment, right? Okay, now that's not a statics problem, that's a dynamics problem. Okay, now let's look at a successful application. This is a little weird. This is a little weird, but we're gonna watch it.
Nobody gets hurt, right?
Nobody gets hurt. So is he applying a moment? He's applying a force at a distance.
Oh my God.
Yeah, I'm gonna stop it. Kind of odd, but interesting. He's using a moment. Okay, let's go to another one. Okay, so these, no one's getting hurt, but these are two situations where there was a failure, but it's not a big failure, so don't worry. Okay, ready? So we have a forklift holding up a sheet of metal. So in that case, they didn't anticipate that the weight of that sheet times the lever arm is going to cause it to turn the forklift. So how should he have lifted that steel sheet?
Well, he just shouldn't have gone backwards. It was fine until he put it in reverse. Then it wasn't fine.
Okay, but besides that,
Or shorter arm.
yeah, shorter arm.
Yeah,
He should have
shorter
kept it closer to him. He had it too far out. Okay. So is this fun? Are you glad we're watching videos first?
Oh yeah.
All right.
Definitely woke me up.
Okay,
Like the
next
teeth
one. Okay, here's another one. So it's a crane that's behind your view. See, here's the crane and the boom is up from here. This is poor quality videos, but he's bringing this in now. What's starting to happen is the soil.
Ah!
He's still okay. He's strapped in. Okay, so in that, they weren't even thinking about the strength of the soil, right? Right? It couldn't handle that load out at a distance.
They need a
Okay.
materials scientist on site.
Geotechnical engineer, actually.
Exactly.
Okay. All right, let's let's go back to the module now. Okay, so here we are, our module. We looked at the overview already. We looked at the videos. These are the in-class problems. And like I said, I'm going to do OneNote to do the problems. Here are the homeworks. And then today we do have a quiz at the end of class, and it's another setup quiz. Right now it's 10 o'clock. Okay, so I am going to pull this off. I'm going to get into OneNote. There it is. Okay, can you see it?
No.
Not yet.
Very
We're
good.
All right,
still
of
looking
course.
at Canvas.
That's right. I gotta change. Hang on, it takes a little bit for the thing to come back on. So let's go back to stop sharing OneNote. Okay, you see it now, right?
Yes. Yeah, that's good.
Okay, let's try it and see how it goes. And I'm gonna keep the oh, what would just happened? I touched it. Okay, do you see it again? Everybody see it?
Yeah, we see the AB with the force going up. Yeah.
Okay, so remember what we're doing. We're looking at a 2D problem, rather a problem in 2D space. And we're looking at this as being my y-axis and my x-axis. So we're looking at the xy plane. Boy. And what I'm going to do is I'm going to be finding my moment. Oh man, I can't even rest my finger down. The moment is we're going to use the right-hand rule, which means my moment is going to be equal to, I'm going to calculate the magnitude by the absolute value of the force times the absolute value of the perpendicular distance. And then I'm going to determine my direction, either positive or negative, using the right-hand rule. So the magnitude I do this way, and the direction I do this way. So what we want to do is we want to find the moment about point A due to this force. So I'm going to start from Adam. Adam, so the moment about point A, is Adam there? Okay, Amani?
Yes.
Okay, what's the magnitude of the force?
100 pounds.
100, right. And what's the perpendicular distance from the force to the point A I'm trying to find the moment about? And remember,
5.
the force is here, right? And it's going up.
5.
5. So I just determined the magnitude. It's 500. Okay, Angel. Angel here?
Yes, indeed.
Okay, now I'm going to determine my direction using the right-hand rule. I'm putting my fingers in the direction of the force. I'm putting my palm towards point A, and what do you get?
Get thumb pointed right at you.
So it's, what is it, positive or negative?
That should be positive.
Positive. And I always come through and write the positive just so that I remind myself that I actually found the moment. So it's equal to 500. And what, Bon, if the force is in the XY plane, what's the moment in? Is the moment in X? Is the moment in Y? Is the moment in Z?
It looks like it's an X. I would
Okay.
think.
Think about this. If I have a pinwheel, right here, right? This is my pinwheel. You know those things you blow on? And I'm blowing in this direction, and it's going around this way. What is the spin around about? What axis?
I'm not sure what I'm looking at.
Okay, so
Oh, right there.
we have one of those spin wheels, and I'm blowing it in this direction, and here's where the pin is, so it's blowing this way, right?
Yeah.
Blowing
So
this
it'll be going
way,
counterclockwise.
it's going counterclockwise around what axis? X, Y, or Z? You want to pass?
Yeah, I think I'll pass.
Colin?
It's spinning around the x-axis. Or the
Okay.
y-axis, I mean.
No.
Oh,
So,
what was that?
what? What were you going to say,
Sorry.
Colin?
Oh,
That's
I just wasn't sure if I'd second guessed myself into the wrong
Okay.
answer or not.
Okay, so it's spinning. I mean, I can't show. Watch, you guys. It's spinning. It's spinning around the z-axis. The force is in the y-axis. My distance is in the x-axis. It's spinning around the z. Can you picture a pinwheel? If you blow it, it's spinning around the z-axis.
Yeah, but that's a little bit of a cheap shot though, right? Because you said it's in 2D space, you know, with the X. I don't know. That's
Okay.
isn't that misleading?
So, say it again. I'm
Well-
I'm not. I'm obviously not trying to be misleading, right?
No, of course I know that. I'm just saying, like, it's not actually in an XY space. It's in an XYZ space.
The force and the distance is an XY space.
Okay.
The moment is going about the Z. So yeah, if we're
Alright.
looking at the forces and the moments, yeah, it's a 3D space. But all the forces and the distances are in the XY space. So remember R cross, put yourself on mute. Remember the R cross F. When you do cross product, R cross F, you're finding the direction vector to be perpendicular to both the force and the distance. So let's go over this again. So the absolute value of the force is 100 pounds. The perpendicular distance to the point I'm trying to find the moment about is 5. When I put my fingers in the direction of force, my palm towards point A, I'm getting a positive value, but it's spinning about the X. Daniel,
I
what's the
have a
unit?
question.
Yeah.
Sorry. Maybe I missed it at the beginning. Are we saying this is specifically the moment at point A,
Yes.
not like at the middle or at F or anything
That's
like that?
correct. We're
Okay.
finding the moment about point A.
Okay, thank you.
And that's why I'm putting a subscript of A here.
Now I got it.
Okay. So 500, Daniel C?
Yeah.
What units is it?
Hold on, let me pull it up. I have the Zoom call in a full screen. Oh, actually, can I pass this one because
Sure.
I don't have my stuff?
Yeah, Daniel Hall, what units?
Pounds.
It's a moment. So it has to have a distance and a force.
Oh, okay.
Right.
So pounds per inch?
Okay, so let's
Is
take
it
a look.
Is it like
5,
inch per pounds? Because isn't it like
5.
the distance?
Hang on a second. 5 is in inches and the 100 is in pounds. You're multiplying the force times the distance. So it has to be in, and remember in the overview, I just showed you guys what the units are. So this is in English, it's going to be inch pound. Okay. Okay, let's do the moment about point B now. So I'm in Daniel I. Again, it's the magnitude. I should put magnitude here. It's magnitude of the force. What's the magnitude of the force?
100.
100. What's the magnitude of the perpendicular distance from the force to point B? I'm
10.
actually going to erase all this other stuff over here, just so that it doesn't. In this case now, my force is still here. So I'm sorry, what's the perpendicular distance from the force to B?
10 inches.
Thank you.
Yeah.
And is it positive or negative? Fingers go in the direction of the force. Palm goes towards B. Is it negative or positive?
Negative.
Thank you. Sound sure of yourself. Let's continue. Daniel, I. So then what is the value of the moment about B?
1,000, negative 1,000 pounds per
Negative
inch.
1,000 K inch pound.
Oh, inch
And
pound.
remember, in the English system, we put the distance first, inch pound.
Okay.
Okay?
Yeah.
David L. Leopold, what do you think this NTS stands for, since you took graphics?
Yeah, that says not to scale.
Good.
What's the K? What's the K you wrote on both of those?
It's in the, it's a vector, right? These moments are vectors.
Okay.
So it's a spin about the z-axis, and the z is represented as K.
Oh, it's like a unit vector in the K. Okay. Okay.
Does this help? I don't know if that helps.
It
So
took me a second. Yeah. All right.
Where is the K?
the
I don't
K,
even see the K. Oh, I see it. Never mind.
okay, so the K represents that it's a spin about the z-axis. You want me to put that in?
Hey, Joanne, on the negative in front of that, does it matter if that's inside or outside the
No,
brackets? Okay.
no, it doesn't matter at all. You don't even have to put the brackets in. I was just trying to, I put the parenthesis here to try not to confuse you what the K is, because the K could look like units of kip. So I put the parentheses so that you know the K has to do with the direction, not the units. Okay? There was a lot more confusion than I had anticipated. So force, to calculate the moments using the right-hand rule, you have the force, magnitude of the force times the magnitude of the perpendicular distance. For point, when I'm trying to find the moment about point A, this is my moment about A. When I'm trying to find the moment about B, here's the moment about B. So this force creates a greater moment. Oh, I'm looking at David LR now. This force creates a greater moment about A or B?
A.
The magnitude, sorry.
Oh, B.
B. When we talk about positive and negative, that is only tells us the direction. I know coming from math, you think 500 is greater than negative 1,000, and that's true on a number line. But the greater the spin is caused at point B. Because typically in statics, it doesn't matter if a crane is tipping one direction or the other direction, it's tipping and it's failing. So the greater moment is at B. And David LR, why is there a greater moment at B?
The magnitude is greater.
The magnitude of what? Yeah,
the
the
moment.
magnitude of the moment is greater, but why is the magnitude of the moment greater at B than A?
Not sure.
Check out the lever arm.
Oh, it's a longer.
Right,
lever.
it's longer. This says not to scale, which means I didn't draw it to scale. They look about the same, but you got to look at the numbers. Does everybody get this? This force is creating a spin about A, and it's creating a spin about B. It's creating a greater spin about B because the lever arm of 10 inches is longer. This force is creating, hang on. This force is creating a spin like this around A, which is positive, and it's creating a spin about B in this direction that's negative. So if you're trying to find a moment about a point, the further the point is from the force, the greater the moment it's going, the greater the moment. Okay, I'm going to stop sharing for a moment. Haha. Questions?
If you were to expand this into vectors that don't align themselves with,
That's where we're going next.
Mhm.
Okay. Okay. We're going to go on. So remember, again, what we did is we took the perpendicular distance. Right? Because at point, we wanted to find the moment about A and B. So we knew, well, I should probably have told you. Let's get rid of this. Shit. I should have told you that this was perpendicular. Sorry, I didn't tell you. So if we're given a force and we know the perpendicular distance to point A, this is how we're going to solve it. Absolute value of the force times absolute value of the perpendicular distance. And then we're finding the direction by using our right hand. Okay, now we're going to another problem. I have to insert a picture from a file. Oh. I guess I'm going to leave it here. Okay, what do we have now? We have this bracket AB, and it has a bracket here too, and this is perpendicular. Okay, so now what I want to do now is I want to find the moment about point A due to the force. So again, I'm finding this moment. I'm finding the moment about point A due to that force. So we're up to Edgar. Edgar, do I know the perpendicular distance between the force and A?
Well, the lever arm A and F are parallel from each other.
So AB, you're correct. Line AB is parallel to the force. But do you see a perpendicular distance between F and A? And let me help by doing this. This is my force, right?
Right.
Remember from before, we always can extend it out. Do you now see a perpendicular distance between the force and point A? Edgar?
I have to pass. I don't know
Okay.
if you did.
Okay. So Elizabeth, do you see a perpendicular distance between the force and point A?
Would that be 7?
Correct.
Okay.
Correct. So let's set this up. We're trying to find the moment about point A. It's the absolute value of the force, which is 150, times the absolute value of the perpendicular distance. This 7 inches here is also here. This is 7 inches.
Because you could put a string on it.
A string on it for what? Try to look at a spin? Let me just keep going, Jason. I want to get the mechanics first, and then we could talk more about the physical. So Edgar, I'm going to go back to you now. So does it make sense? It's 150 times 7 is the perpendicular distance between that force and A?
Yes, yes, I see it.
Okay, and now we have to find the direction, and we use the right-hand rule. Put your finger in the direction of the force, put your palm towards point A, and do you get your thought, is it a positive or a negative moment?
It's positive.
Positive. So what's 150 times 7? 1050.
1050.
And what would the units be, Edgar?
Is it forces in pounds? I don't see it. Oh, yeah,
Right, so this is pounds.
So
And in
it's
English,
inch
we
pound.
always, right,
Inch
inch
pound.
pound.
Yeah, it's just I didn't see the unit for the force.
Yeah, no problem. Yeah, it's okay. So 1050, and we said it's positive. And I am going to put my K in here because I know the spin is going about point A. And so you could see my hand, I guess. Put your finger in the direction of the force. When when I teach in person in statics, hardly anybody uses their right hand rule. So, and I can't see you now. So please, everyone, put your fingers in the direction of the force and put your palm towards point A, and your thumb should be sticking out, and it's positive.
Can I clarify what you mean by palm towards? Is that the normal to my palm, or it's like the alignment of the bones in my palm are pointing in a direction?
Okay, so push your fingers up. Put your fingers the way they were. Okay, so your force is going in the direction of the fingers, right? And
Okay.
now your palm, where's your palm? Put your hand on your palm. Put your other finger on your palm. Put your hand straight still. Your palm is, that's it, is pointing in the direction of where point A is. So is the point A towards the left of your head? Put your finger towards point A. Right. And then your thumb is going in the positive direction. You got it?
So when you say palm pointing, you mean like the surface normal of my palm would pierce A.
Yes. I guess you could say face your palm towards the point you're trying to find the moment about.
Okay, that's more clear.
Jason, in this example, your hand would be horizontal, right? Because F is horizontal. It's the yellow
Right, but
line,
he would,
right?
he would just, yeah.
So you'd start like that, and then your palm is facing A.
Okay. So my force is going up. Hang on a sec. My force is going up and my point A is over here. So I'm facing my palm in the direction of where the point is. And my thumb is coming out at me. We're going to see the opposite now in the next problem. Okay, I'm going to go back. Okay, can you see the screen again? Okay, so now I'm trying to find the moment about point B. It's the absolute value of the force, 150, times the absolute value of the perpendicular distance. And now, Eric, what is the perpendicular distance from the force to point B?
7 inches.
7 inches. Okay, is the moment positive or negative? Put your fingers in the direction of the force. Put your palm facing point B. And do you get a positive or negative?
It's positive.
Positive. Yeah, Jason, I see what you're saying, David. Jason, your fingers, put your fingers in the direction of the force. It's horizontal. Right. Palm goes towards B. Which way is your thumb pointing?
Towards me, so it's positive.
And it comes out to be 1050 inch-pounds. Okay. Now I want one more. I want a moment about point C. So Gerardo, what moment does this force create about point C? Do you see point C? It's right here.
Nothing, right? Because there's no
Zero.
perpendicular
Excellent.
force.
Great. There's no lever arm. It's going right through. You guys, I'm stopping sharing. This is too visual. You need to see my hand and you can't. I'm not using OneNote. I'm going back to the document camera. Okay? So why don't you guys talk? I have to get off this laptop. Well, maybe I don't have to. I don't think
So in physics, what we would do is we'd say the radius, like the bones of my hand here would be aligned with the radius, and then fingers point force was the way that we'd say that. So this would be like the lever arm, the force points this way, and then thumb tells the moment.
So you guys could do it whichever way you want. I noticed that in statics, students start out, wanting to do it the physics way, and then once they get the engineering way done, they stick with it and they say they wish they did it the engineering way the whole time. But you might have an opinion, but that's what I find typically. So you could put your fingers in the direction of R if you want, and then your palm goes towards the force. You could do that, but I like this way, and this is what I'm going to show you, but you could do whatever you want. Sorry, I'm seeming a little frustrated. It's just really the technology. I just wish I was in the classroom walking around,
Of
touching
course.
your hands to put it in the right direction.
Yeah.
Okay, where the hell is the cursor now? Come on. Let me just make sure it's in. Come on. Okay, there it is.
Jason, it might be easier to just think of clockwise, counterclockwise, especially 2D, because 2D, I think it's always going to be counterclockwise is positive and clockwise is negative. I think that might lead to issues in 3D, though.
You could do that because we're going to be looking at each axis.
Oh, so if you say clockwise around an axis, counterclockwise around an axis, that'll always sync up to
Yes. Yeah, 2D and
counterclockwise
3D.
positive, counterclockwise
Correct.
positive. Okay.
Correct. It's not seeing the document camera.
And we already saw that the force that's aligned with an axis, like pointing out from the origin, is considered positive. And pointing towards the origin along that axis is considered negative.
Come on, baby. I'm going to get out and come back in.
Okay.
I have a question. Do you guys understand if the radius that's set, the distance, is it always perpendicular to the force or to the point?
To the force vector.
Yeah, so in that last example, A and B had the same distance. It was 7 inches to the force. So from A to the force and from B to the force was the same. They were both 7.
Okay.
Even though the force was actually being applied at a different point. That's interesting.
Because you can extend the vector like as much negative or positive because it's just the direction, I think.
Yeah, I think what it's measuring is like how far away from your point you're getting the force, right? So if it's really far away, that's going to multiply it for, that's going to be a higher moment because it's bending a bigger arm, I guess, is the idea.
Just like the perpendicular component though, because like B is farther away from our force than A is in the second example, but it's the same moment.
So I think I think that's the idea where you could draw that force, the line, the line of force F is a really long horizontal line. And so it's like how far away in the perpendicular from the force. Perpendicular from the force to the point.
Okay.
Well, that's kind of counterintuitive to me. The are we saying that it doesn't matter how long B is? You would have the same. Wait, no, I guess is that what we're saying?
Well, what would change it is the length of the I guess the bar to C, the arm that goes up.
It's
If that
7
was
inches.
longer, if the 7 was longer, that would be more moment, right? Because then it would be a longer.
That's the only thing that can change it. Yeah, I think that's what we're saying. We're saying the only thing that matters is the force and that 7-inch bar. It doesn't matter how far away the 7-inch bar is from point B. It won't change the moment.
I think that's true. Yeah, I
That's
think that's
messing
right.
with me. That's full on messing with me. Because I mean, just imagine like extending it like way out into the distance. Like you wouldn't. Doesn't seem like you'd have the same.
Okay, you guys, I'm back. Okay.
We're making progress. I think we're having a
Okay.
good discussion.
Yeah, it was probably good to have the discussion. So we loved technology in that moment, right? So you had some time to talk. Okay, this is what I decided. I just lost a bunch of time. The quiz that I was going to have in class, I'm going to have you take outside of class so that we continue to do this and finish and make sure that I'm comfortable with you guys, okay? With the knowledge. So we're going to take the quiz, the in-class quiz today. You're going to do it outside of class. Everybody thumbs up?
That's good.
Okay, so I'm going to have to change the time. And I'll just make the time till midnight or something today. Okay, so I am going back to my comfort. I am using a document camera, so I could put my hands here and show you what I'm doing. Okay? And aside, just a little comic relief. How many of you are lefty? Are any of you lefty?
Oh, there we go.
Louis is. Okay, well, let me tell you. The lefties have an advantage here. Why? Because we could write and do the right-hand rule at the same time.
Ah,
Too
there
bad,
you
you righties. You have to put your pen down to do the right-hand rule. Too bad.
Ha 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 ha.
Okay. All right. Okay. So let's move into here. So you guys, I'm using the document camera, and you just tell me when it's not focused. But this is better. It's easier for me. I'm more comfortable. All
Work
right.
on the focus a little bit.
Yep, I didn't get there yet.
And here's a tech point for students. Now you can pin Joanne's paper. You could pin her window, and then it'll stay big even if other people are talking.
Double click.
Okay, how's it look now?
Good.
Great.
Yep. Okay, so we found the moment about point A. So I do like the idea of using the colors though. So remember, our force goes through point C, right? And it's 150 pounds. And in the first case, I'm trying to find a moment about A. The perpendicular distance right here between the force and the point is 7 inches. When I'm looking at B, the perpendicular distance between the force and the point is 7 inches. And, you know, if you're struggling with this, don't worry. It's just going to take a little time to get used to. But let me tell you, we're going to be doing this in 3D space. And that's all we're going to be doing the rest of the half of the semester. All 3D right-hand rule. So just put extra time in now. Okay? So I want to just go back. You guys, here's the force. Here's the force. Here's the point I'm trying to find the moment about. The perpendicular distance is 5. When I'm trying to find the moment about B, the perpendicular distance is 10 from the force to the point. So the first thing you do is figure out where is the force. Here's the force. And if you want, draw a big old long line. Then when you're trying to find a moment about A, here's the perpendicular distance. Here's B, here's the perpendicular distance. I need to know, are you guys somewhat comfortable with finding the perpendicular distance now? Yeah? Okay, so now let's look at this problem. Notice here, I want to find the moment about A, B, and C. And we were at Cody last, so I'm sorry, no, we were at Gerardo last. Hyoji, where are you? Okay, Isaac. What's the moment about C due to this force here?
0.
0. Why?
Because the force passes straight through it. There's no lever.
No lever arm. Okay, so if I drew this to scale, this is actually where the force is, right? So what did we do? The first thing we do is we look at where the force is. Second thing we do is we find the perpendicular distance. We are not going to find the perpendicular distance. It's too much math, too much geometry. So let's think about what we can do. Okay, so does everybody, are we writing down steps? First, find the force. Second, can you see can you is perpendicular distance written? I don't know if that's a good way of describing it. But here, in these two questions up here, we were able to see the perpendicular distance. It was a distance given. Is perpendicular given? That's good. Is the perpendicular distance given? That's my question. So, Jack, is the perpendicular distance given to find the moment about A? No, it's not. And we probably could do it by geometry, but we're not going to take our time to do that. Instead, is the perpendicular distance, yeah, if it's no, then the next step is to break force into components. Okay, so I'm going to take this force now and I'm going to find the CY component and I'm going to find the CX component. Because now with the components is the perpendicular distance given. Jason with an E. So when I had the given force, I find the force, I was looking at the perpendicular distance to A, it's not given, so I'm breaking the force into components. Can I now find the perpendicular distance from CX force to point A? It's just a yes or no.
Let's go with yes.
Okay, and the CY. So let's find the force. So I'm going to, C is equal to, and remember I said you could start using sign if you want now.
The force is F, right? Not C?
Oh yeah, why did I say C? Oh, because it's coming off point C. But yeah, you're right. Let's call it FX. Sorry, FX and FY. Thank you. So C, I'm not going to call it.
FX would be negative 86.6.
Okay, but I'm going to do it the way we always do it, right? Well, 3 steps. F is 100 times, notice what I'm going to do. I'm going to say the negative cosine of 30i plus the cosine of 60j, and it's pounds. And notice I'm going to skip our second step from now on in statics. It comes out to be negative 86.6i plus 50.0j pounds. And then what should I do once I calculate that force? Not moments. When I find components, what do I do once I find components?
Checks.
Checks. So plus or minus visual check. Let's see. I got a negative for X. Yep. I got a positive for Y. Yep. Okay. And then what's the other check? 86.6 squared plus 50 squared under the radical, and it does come out to be 100, and it's okay. Okay, so I'm going to stop for a moment. Is everybody with me? I first found the components, like we have always done, right? We have always done components first. We did components before we did the resultants. We did the components before we did the statics problems. And now we're doing the components before we're doing moments. The only thing different, you guys, did you notice I skipped step 2? I'm skipping it now. You know how to do it. You know it's a unit vector. I'm skipping it. But what am I still doing? I am still doing my checks. Jason with an O. Just Jason Lee, why am I doing checks?
Because you want to make sure your answer comes out correct.
Right, so you want to check, make a check. If you screw up here, you guys, the whole fucking problem's going to be wrong. Right? So you want to catch if you made a mistake up here. So we always solve components and we always do a check before we move on. Okay. Okay. Jordan. So now I want to find the moment about A, and it looks like I'm going to need to get a different sheet of paper. Everybody has the components. I'm now putting this over it. So the moment about A. So I'm going to look. Okay, everybody, or Jordan. If this force here is going up diagonal, is it going to create a positive or a negative moment about point A using right-hand rule?
I think it would be a positive moment.
Correct. My fingers go in the direction of the force. Palm goes to where I'm trying to find my moment about point A, and my thumb is sticking out. It's a positive. Fingers go in the direction of the force. Palm goes towards where I'm finding my moment about, and I'm getting a counterclockwise. So I know in the end, it should be positive. Cody, why did I break the force up into components?
Because there wasn't a perpendicular distance available.
Right. The perpendicular distance wasn't given. But when I break it up, I can now find the perpendicular distance. So the moment of A, notice I have two forces now, right? I have an X and a Y. So it's going to be equal to the perpendicular, the X value, which is 86.6 times, Cody, what's the perpendicular distance from FX to point A? Here's the force.
Would it be 7?
Yep. 7. Positive or negative? Fingers go in the direction of force. Palm goes towards where my point is.
Positive?
Positive, right. And then the Y component is 50, absolute value, times, let me go on, Laura, now I'm looking at the FY. Here's FY. What's the perpendicular distance from FY to point A?
0.
You try it again. Here's FY, right?
Uh-huh.
Right? And here's point A. What is the perpendicular distance from the force? Force is going like this. Here's the force. Here's the point.
Oh. Uh-huh.
What is it?
5.
Right. And now, is this FY creating a positive or a negative moment about A? Fingers go in the direction of the force.
Positive.
Positive. So what does this come out to be? I have the math in front of me.
Joanne, I'm sorry, are you adding those?
Yes, I'm adding them.
Okay.
The reason why is that if this whole force, you agree, is creating a spin this direction, right? I broke the force into two components. So this force is creating a spin this way, and this force is creating a spin this way. I have to add them together.
That's
Okay,
interesting.
so adding them together is 856.2 inch-pound, and it's positive, and it's in the K direction.
Joey, I have one question.
Yeah, Angel.
I don't understand, or actually, I'll just wait until we move on to moment B.
Okay, great. Okay, so let's do moment B. We don't really know, unless this was drawn to scale, we don't really know whether this force goes above B or below. We don't know. We just know it's over here. But we broke it up into components. Does everybody agree? The reason I do not know the perpendicular distance from B to the force. Does everybody agree with that? Okay, so I have to do them separately. So I am up to Liam. Liam, so I'm calculating the moment about B due to Fx. So Fx is 86.6. What is the perpendicular distance from Fx, here's Fx, to point B? What is it?
7 inches.
Great. Positive or negative? Fingers in the direction of the force. Palm goes towards the point I'm finding a moment about. Positive or negative?
Positive.
Great. Okay, now we do the second part of it. Fy is 50, absolute value of 50 times the absolute value. Luis, what is the perpendicular distance from Fy to B?
10 inches, yeah.
Great. Does it create a positive or negative moment?
A negative moment.
Great. Fingers. Everybody watch me. Look, eyes on my fingers. Fingers go in the direction of the force. My palm has to point to the point I'm finding the moment about. Here's B over here. My thumb is going into the page. It's negative. So everybody do that. Fingers go in the direction of the force. Palm goes towards the point I'm finding my moment about, and I get a negative. Okay. And the moment about B turns out to be 106.2 inch-pound, positive.
Sorry,
Come on,
can you say
Jason,
that one more
wait,
time?
Jason, wait for a minute. You're always anticipating where I'm going, and I want to give everybody a moment before I move in that direction. Okay, so everyone, what was the first step? You look for where the force is. The second step, is the perpendicular distance given? If the perpendicular distance is given, you calculate the moment about the points. So in these first two problems, the perpendicular distance was given. I'm going to go a little over in today's class, sorry. In this problem, you saw the force, but the perpendicular distance was not given. So Mackenzie, is Mackenzie here?
Yes.
Okay, Mackenzie, in this third problem, the perpendicular distance was not given. So what did you do with the forces? Or rather, what did you do with the force?
Sorry, you cut out. What did you ask?
In this third problem here, the perpendicular distance was not given. So what did you do with the force?
I'm sorry, Joanne. I think my internet's.
Okay. Marcine, Because the perpendicular distances weren't given, what did you do with the force?
We split it up into components.
We broke it up into components. The way we always do components, except now, from now on, we're skipping the second step, and you can use sign if you want. Just make sure you do these two checks. I'm not going to go to 11:15, Isaac. Don't worry about that. Don't go. Thank you. So everybody got it? Look at the force. If you're given the perpendicular distance, you solve for the moment. If you're given a force and you're not given the perpendicular distance, then you break the force up into components the way we know, and then you look for the perpendicular distance. Okay, now, here's the question, and this is where I think Jason was going. I got a positive. Nobody call out the answer. I want to give you time. We got a positive moment about B due to this force. Does that mean F is in position 1, or don't answer out loud? Think about it. Where is this force? Is it above B or below B? So think about it. In order to get a positive moment about point B, is this force above or below? Okay, Maria, what is it? Is that a pass?
It was a positive.
Okay.
Above. It's above.
Above. It's above. Why?
Because of the right hand rule. If it's above, then your palm is facing down. So
Right.
Your fingers are.
So fingers go in the direction of the force, palm goes towards B. So the fact that in this case, I'm doing the opposite. I know I got a positive moment, which means my thumb has to be coming out of the page. And I know my palm has to go towards the point B, so my force must be above. So this is not possible. Okay, now I want to do one more thing on this. Oops, went too far. You can still see the problem, right? We know the moment is equal to the absolute value of the force times the absolute value of the perpendicular distance. Okay. We got a moment about A equal to positive 856.2 inch-pound. What is that perpendicular distance? So we're up to Matthew. Matthew here. Myra, you get the hard question. You ready? Not too hard though, it's algebra. We know that the moment is equal to the force times the distance. I want to find the perpendicular distance. How can I find the perpendicular distance? Going from this equation. Isolate this. How do I find that?
Move it over to the other side?
Yeah, so the moment, it's equal to the moment divided by the force, right? If I want to find R, I move F over to the other side. And remember, it's all absolute value. So my moment is 856.2. Oh, sorry. 856.2. And my force was 100. So what is this perpendicular distance? 856.2 divided by 100 is what? 8.56 inches. So if I wanted to draw it, you could still see the picture, right? Let me get another pen. Here is my perpendicular distance. and it's 8.562. Everybody see that? I went backwards. Remember, we didn't know the perpendicular distance. We took the force, broke it into components, solved for the moments by multiplying the absolute value of the force times the absolute value of the distance, the perpendicular distance. Used our hands, our right-hand rule, to find positive or negative. And now I'm going backwards. I'm saying, well, I now know the moment about point A is 856.2. I know the force is 100. So can I solve for the perpendicular distance? Sure, I can. So let's do the other one. The moment about B I know is 106.2 inches. If I want to find the perpendicular distance here, the perpendicular distance here between the force and the point, miles. Miles, how would I calculate that perpendicular distance?
So, Miles, I see that you're talking,
Oh,
although
Miles.
we don't hear you, which happens with Miles sometimes. Can you put it in the chat?
Right. And not only is it moment divided by force, I have to remember to put absolute value because I don't want a negative distance. It's a perpendicular distance. It's neither positive nor negative. That's why it's called the radius. So it's 106.2 divided by 100, and R perpendicular equals 1.062 inches. I'm not worried about decimal places right now. Good? Okay, let's do another problem. So you're going to need a lot of practice on this, okay? And I already posted the homework. Okay, I already posted the homework. So I'm going to the other sheet. Okay, so take a look at this. What's the first thing? Look at force.
Focus bad.
That's
Focus
blurry,
very
yeah.
bad.
It was probably focusing on my finger, my hand. Okay, first thing is look at the force, and I wrote forces. Take a look. So this is a bracket. Let me that's a bracket. This is 25 feet. There's a bracket, and there's a force here, F1. There's F2. And notice I'm putting this on here, you guys. And of course, you know X and Y. There's F1 coming off the top part of the bracket, F2 coming off the top part of the bracket, and F3 is on the bottom part of the bracket, the vertical. Look what I'm trying to find. I'm trying to find the moment about point O. So first, I look at the forces. Second step, are perpendicular distances given? So now, let's look at, I'm going to write these up separately. I'm going to say the moment about O. Well, let's not write it here. I'm going to say the moment about O due to F1 the moment about O due to F2, and the moment about O due to F3. Does everybody see my notation? Take a look. The moment about O due to F1. The moment about O due to F2. Moment about O due to F3. Maria? Do all these forces have the potential to cause a moment about O?
Yes.
They could all cause it to spin, right?
Yes.
Maybe the spin 0, but they could all cause it to spin. So in the end, the total moment about point O, the total moment about point O is due to all of these. Okay, so we're up to Peter. Peter?
Yes.
So I'm trying to find the moment about O due to F1. Here's F1. Is the perpendicular distance from F1 to O given?
Yes.
Great. So I'm just going to go through. The force is 30. What's the perpendicular distance?
It's going to be 75 feet.
Great, 75. And now positive or negative? Fingers go in the direction of the force. Palm goes towards the point I'm finding the moment about. Positive or negative?
It's negative.
Negative. So it comes out to be, what's that, 225?
I believe so. $2,250.
Yeah. All right, I'm just going to get the number from you guys. Here it is. 2250. It's foot-pound. Oh, and I got to write the feet first, right? Foot-pound, and it's negative. Okay, Tim. How about a moment about O due to F2? Is the perpendicular distance given? Tim, are you here? Tim, put your speaker on.
There we go.
Okay.
Yes.
Okay, so then I'm just going to go ahead and do it, right?
Yep.
What's the force?
40.
Perpendicular distance?
25.
25. Positive or negative? Fingers go in the direction of the force?
Negative.
Negative. Comes out to be 1,000, of course. We should have figured that one out. Foot-pound, negative. And I should put my K here. I have to get in practice of making sure. We know that when the forces and the distances are on the XY plane, the moment's going to be about the Z. Okay. Tony.
Yeah.
Okay, Tony. So on F3, here's F3. Do you know the perpendicular distance between point O and, the perpendicular distance between F3, here's F3, and point O? It would be this, right? Right here?
Yeah, up to about there.
So is it given?
No.
Tony, it's not given. Can we find it really quickly?
We could, yeah.
We could. What is it?
Well, I mean, you can see that the angle right there between the red line and the black line is about 30 degrees, yeah?
Yep, is exactly 30 degrees because it's 30 here and 30 here. So what's this perpendicular distance?
I'm not sure. Can't really.
So think about dot product, right? We know this distance, and here's the angle between this and this, and we want to find the component of this distance in this direction. Wouldn't it be 100 times the cosine of 30 degrees? So let's do it math-wise. We have this triangle. It's a right triangle. This is 100 feet.
Yeah,
right? We know this angle is here. We want to find out what this value is. Well, the cosine of 30 degrees equals x over 100. So x equals 100 times cosine 30, right? We could do all this. We know this from trig. Is everybody with me?
Yeah.
We know this from trig. But now, we know dot product, in and out, everywhere. This is here's a distance. We have an angle. We could find.
I thought we wanted that opposite distance, didn't we? Because we wanted to know the perpendicular distance to O.
Good, but look, take a look again. This is the force in green, right? Here's the force. Here's the point at O. Isn't this the perpendicular distance?
Oh, yeah, I see.
Right? So what I always do in these problems, until I got really good at it, is I put a marker along the whole line of action of my force, and then I look at the point and I see it more clearly. Can you guys see? Look, everybody look at the green line and look at the green dot. You could see this more clearly, right? Where the perpendicular distance is. Okay? It just takes practice. So everybody knows how to do this trig, but if this is 100, if this black line here is 100, and this is 30 degrees, I know the component of this direction is going to be 100 cosine 30. Okay, so go back to the steps. The first step is look at the force. The second step is the perpendicular distance given. In this case, it's not, but you could calculate it like that. If you feel like you can't, well, then you have to convert, you have to make this into perpendicular to this axis. It would be more complicated. Find the perpendicular distance the easiest way you can. So now, Victoria? Victoria, you on?
Yes.
Okay, so what is the value of the force?
20.
20. What is 100 times cosine of 30?
86.6.
Great. And it doesn't matter whether it's positive or negative, right? We only need absolute value. 86.6. Is it positive or negative? Fingers go in the direction of the force. Palm goes towards the point. Negative or positive?
Negative.
Negative. And it comes out to be negative 1732. Okay, again, foot-pound. Okay, did Adam come back on? Okay, Amani. I need to keep going. I'm not finished. Because the question asked me to find the moment about point O due to all the forces together. So what is the total moment about point O?
We just add the sum of all the moments?
Yep. And it comes out to be negative 4982 foot-pound. So let's think about it. So look at where point O is. All the moments were negative. Does it make sense? F1 is creating a spin this way. F2 is creating a spin this way. And F3 is creating a spin this way. They're all creating negative spins, clockwise spins around point O. Okay, do you have a question about on the paper? Oh, yeah, somebody asked, is the moment? Yeah, it's still K. Everyone, in a 2D problem, the spin is always about the K. You don't have to write the K. It's a 2D problem. The moment is going to be about the Z. But when we get to 3D problems, we're going to have to write where the spin is about, I, J, or K.
And it might be a combination.
And it's going to be a combination. And we're going to, hey, do you guys have tops at home?
You got one?
Oh, you can't see me yet. Okay, I'm going to get off. Oh, there it is. Everybody, could you all get a top? $2, $3, get a top. Or make a top.
Out of a gumball machine.
Okay, get a top for next week. I'll put it in the homeworks. Get a top. This used to spin. It doesn't, I mean, it used to make a noise. It was very fun because we all had, in class, we would all have tops because I have a whole box of them in the storage cabinet. And we would all spin them and they'd all be making noises. It was very fun. But, oh, but we could still do that. Get one that makes noise. Go to a kid's store. I bet there's one at Target. There's a store at the end of 41st Avenue where the vacuum store used to be. There, they'll have one. Downtown Santa Cruz, probably, what is that, Paper Vision? That'll probably have one. Or call first. I always call first. Get a top. Oh, order it online. You might be able to get it in 2 days.
Palace might have.
Palace may. Okay, so where am I going? I'm stopping the sharing. Oh, I wasn't sharing at all. I was just using the different video setting. Okay. So let's go to okay, I'm going to share now. Okay, everybody can see my screen for the module for today. So you could watch the videos. I posted the homework already. It's due Friday evening. Remember, I'm doing 2 sets of homework each week, so we don't have a zillion homework to do on one homework thing. And these are all the problems we just worked on. Okay? And what I'm going to do is add just text. Have a spinning, have a top. You know what a top is. For class on Tuesday, September. What's today? The 22nd?
Yep.
Plus 7, 29. Okay. All right. So again, I wrote the overview. I'm thinking, can you see the overview or no? Probably not. Can you see my overview?
Yeah, that works.
You can. Okay. So I wrote down all this stuff that you need to understand, but I think what I will add in here is I'll add steps. So what were the steps? 1,
Find the force.
find the force. 2,
Is perpendicular distance given?
is the perpendicular distance given? And hang on a second. Okay, So the palm thing was confusing. Your palm faces, not goes in.
Yeah.
Faces the direction of the point you are finding the moment about. Okay, is a perpendicular diff? If yes, well, let's say if no. If no,
Break into components.
break components. Two-step process. And do plus or minus visual and magnitude checks. And then 3 is follow this. And then 4, should I write the total, wait, the moment about a point is the sum of the moments due to all the forces. Is that clear? Good? Everyone? It's okay? Okay. All right, so now let me save this. Okay, and now I'm going back to the module. So you have the videos, watch them, hear all the problems, go over the problems, and then do the homework. Okay? And on Thursday, we're solving it vectorially, meaning R cross F. We're going to find the R vector in vector form. We're going to find the F vector in vector form, and the moment is going to be R cross F. You're going to like this initially because it's easy. Or I find static students find that this is easy because you did all vector analysis in physics. What we did today using the right-hand rule is a little more complicated. Okay? But it would be awesome if you could get this homework 9 done before Thursday, if you can. Okay, but it's due Friday night. Okay, it's 10 after 11. That means I used 20 extra minutes, and I still haven't given you back the other 10 minutes. So I owe you 30 minutes. Okay, I'm going to stop sharing. Any questions, and I'll be on for a little bit still if you have questions, and also I have office hours at 1.
For the online quiz, is there anything we need to do beforehand, like watch any videos, or is that just straight into the quiz?
Yeah, look at the module. Oh, no. I'm sorry. No. I'm thinking about the other one. No, it's an in-person video. Okay. God, it's an in-person quiz, so there was nothing you needed to do except if you had a cheat sheet and not a 3x5 card. Now, does anybody work tonight? Jordan?
I'm busy afternoon.
What's the hours that you're
So
busy?
I work from 3 to sometime. I don't know. It's hard to tell. They don't really tell me how long my shifts are.
Is it ever midnight? It could be.
Never has been, but it's been kind of inconsistent lately. It
Anybody
probably-
else? Does anybody have class? But Jordan, what time do you work? You said 3?
I work at 3, but I have to do something beforehand.
Okay, I can't work everything. I might just have to work around you for you taking the quiz. Everyone
I take
else.
the quiz right now?
Yeah.
Okay.
Yeah.
I could take it right now.
So you guys, if I have the quiz open up now till 4 o'clock, will that work for everyone?
That's good.
Does anybody not have an hour free between now and 4 o'clock?
I don't.
Okay, what's your schedule, Gerardo?
I have to go do something at 11:30.
And then when are you free after 4? When do you get free?
Hold on. Whenever the communications class ends.
Oh, that's
Okay,
that's like 5:30.
5:30. Actually, I'm teaching in engineering 10 today. Okay, so I'll make it from now until 7. You guys, I need you not to be looking at each, the quiz is on your own. It is on your own. It's the only way I can assess where you are now. If you get a 10 because you cheated, then I don't know that you don't know the material. And we're going to just keep flying through this stuff. You really have to be on your own. Okay, so I'm going to open it up now to 7. Okay, good luck, you guys. And
Hey,
I'm going to
Joy.
hang on for a little bit.
Real quick, I tried looking up tops on Amazon, stuff like that, and the soonest they would get here is the 29th.
Okay, so then you get it from a store. Call
yeah,
a
we would
store.
have to get them from store.
Thanks for checking, Daniel.
Look around in town. There's got to be stuff.
Okay, so I'm going to lock the quiz from 11:30 to 7, and then everybody should be able to do it. Okay, I'm going to do that now, and those of you who want to hang on with me, do so, but I want to get this ready so those can start it.
Okay, thanks, Joanne.
Yeah.
Thanks, Joanne.
Eleven 30 to 7. Okay, you guys. So yeah, I just put it on. It's going to open at 7:30, and then it's open. Sorry, it opens at 11:30, and then hang on a second. Okay, it opens up at 11:30, and then it closes at 7 p.m. So it should be good for everyone. Okay, Tony, Jason, any questions?
Yeah, I'm working on the lab right now.
The lab. Oh, okay. The pulleys?
No, this is the vector lab that's due today. The calculator lab.
Oh, the calculator lab. Okay. Okay, and Tony, how about you? Any questions?
No, I was just
If you guys
hanging
don't
around.
have if you guys don't have immediate questions from the lecture, I probably would prefer to get off right now, and then I could see you at 1.
I have an immediate question for the lab, and I'm not available at 1. Are you able to?
Okay. Yeah, sure.
Hang on for 1/2 minute. Come on, okay. All right.
Great.
So this is solving for moments.
Great.
And
meters and newtons. Awesome.
okay.
Yeah.
And so then I have my determinant set up there.
Great.
And
Okay, so hang on a second. Let me just come down. Yeah, hang on. Oh, you did the math in your head. Okay.
Correct.
120.
Yeah, it wasn't too much.
Since I write everything out, like it's just, I do everything. Okay, so the signs look right. Then negative, you do a negative, and you have a negative pos. Oh, check J, where it says J is equal. times negative 60 minus 75. The 75, check that sign.
These are both negative.
Right, so what should it be here? If you're multiplying a negative 0.25 by a negative 300, should you get a negative 75 or a positive 75?
Well, you get a positive 75, but it's this minus that. Right? That's why this one was positive, because it was this, which is a negative.
Oh, I see. Yeah. I got it. You're right. Thank you. Sorry.
Sure.
Okay. Minus this. Yeah, so I always write everything out, so it's, yeah, okay. Yeah, great. It looks good. And you got an X, Y, and Z component of the moment. Great.
Sure did.
What?
And then your second request, the second part of it was to use a calculator.
Yes.
To I don't know what you mean, because if I do, so one thing I can do is I do 1, -1, 1,
right,
and I obtain a determinant. I'll tell you what, I got, yeah, when I add these numbers, I get the same number. So I've confirmed that I did this right.
Right, but if you put in,
but I don't get the IJK.
Right, which means you can't do that.
I have to do these individually.
Yes, so the calculator can do determinants. It's happy doing determinants.
It totally is.
But it will not do a determinant with variables in it. So putting in an IJK, which they're not variables, but they're letters, it can't do it. So the only way the calculator could do a determinant is if you break it out the way you did and do a 2x2 determinant.
Yeah.
Because in the end, this force is creating a moment that has an X, Y, and Z component of a moment.
Right. Yeah, right.
So it's like a top that's not spinning completely vertical like you want it to spin. It's spinning to the side, and you're getting an X, Y, and Z component of it.
Very cool. So yeah, so you said use your matrix feature to complete this step.
Right, but you have to do it as a 2x2.
I see. Okay.
Was that, maybe I should make that clearer in the question?
Yeah, because matrix feature, I wasn't thinking like determinant is a different function than like RF or something on my calculator, right? And as it would be.
What's RF?
Reduced row echelon form.
Okay, so what I know is
what I used to solve the first part.
So my calculator, you have to get into the matrix function first, and you put in a 2x2 matrix, which would be here. This is a 2x2, right? And then you hit the button called determinant. So they're all underneath the matrix function on the calculator. Are you listening, or are you doing something different?
I'm listening.
Okay.
If you're showing something, I can't see it.
No, I'm not.
Okay.
So I understood when you find a determinant, you're still in the matrix functions on your calculator.
Yes.
Right? So let me see what my wording was, okay? Let me look. Okay. Tony, I think it's great that you stay in, because I would do this too as a student if I had the free time, because you're just getting extra,
exposure
stuff, right? So, okay, could you stop? Oh no, you're not sharing. Okay, I'm going to share.
Okay.
So I can make sure the wording makes sense. Using the system of equations function on your calculator. Okay, it's the bottom part. Calculate the moment about point C using this. Using the matrices function on your calculator, solve for this.
Matrices, the determinant of matrices function.
Yeah, okay. I'm trying to figure out how to say it because you're not just using the determinant. You first have to put in R, the R vector into your calculator. Then you have to put the F vector into your calculator. Then you have to put in, then you insert the 2x2 matrix. And then you use the determinant. So I don't want to say you're just using the determinant. Maybe I should say matrices function. Let's see what I wrote up above. Using systems of everything. Set up the matrix by hand and using the matrix solve for this. Check to make sure that you calculated the same value. Using the matrix function on your calculator. Functions. Check to make sure that I think I'm going to leave it like that. I don't think I'm going to put determinant because determinant is just one of the matrix functions you're using. You first have
put the word determinant somewhere, would you, right?
Well, then they're going to think that they should go straight into determinant and they can't. They first have to, when you go into the determinant function on your calculator, does it prompt you for the radius and for the vectors? I don't think it does.
Oh, no, but what I'm saying is that, we need to use the determinant feature to get these values. I mean, yeah, you enter a matrix, that's this, but then the action that you put on the matrix, the feature you apply is, or method, is determinant. You could say, use the determinant feature on a matrix in your calculator.
Input vectors. Set up 2x2 matrix. And set up. I think these details are going to confuse the hell out of people.
Hey, I'll take your word for it. All right.
I think when I give details, they're going to be like, well, what do you mean? Why are there 3 2x2 matrices? Let me just, let's see if I do it. Input vectors, set up 3 2x2 matrices, solve determinants. I don't know. We'll see. I just think that I'm going to get more questions now. The idea is they should just watch the videos that I put on here.
But you don't demonstrate using a determinant in the video.
Okay. All right, let's try it. Let's see.
Yeah. Like, how would they get that idea?
I don't know. I don't
like
know.
so Joanne, you show them how to do the cross dealio, but I don't recall that you associated that with the word determinant, which is key if they're using the calculator to do this arithmetic.
Oh, so you think people don't know the term determinant? That's what you're saying.
I don't think you used it. Yeah, you did this,
but
that's
yeah, but they don't know it from math. The word.
Well, I don't think it's obvious. I don't see any reason why you wouldn't imply it. Like, by the way, what you're actually doing is a determinant of this matrix.
Ah, okay.
It took me a year to it was like I didn't figure that out initially when we started doing this in 5C or whatever. I was like, oh, that's a determinant. There's an aha moment that's like you really need to put in here.
Okay, so I apologize when I gave the video, I didn't use the word determinant.
I do not recall the word, yeah.
Okay. All right, so yeah, that's...
Because I went back and watched it again because I was like, wait, how is she expecting... Like, I had my ways to do this, but I'm trying to do your way, and how I was not clear how...
Right, okay, determinant. Okay, yeah, sorry, I should have used the word.
All good.
Maybe I should put a little caveat here. I just assumed I used the word determinant. I don't know why I didn't use it.
I went back and I don't
so it's fine. If I didn't do it, yeah, it's a problem. But I didn't understand. I thought you wanted me to teach, you wanted me to write how to find it, but you're actually just telling your comment, I now understand, is that Joanne, in the video, you never use the word determinant, so people might not know what a determinant is.
Well, they wouldn't go to that menu feature in their calculator. They wouldn't even think of it. Yeah.
Okay.
I actually got
Wait, I have to figure out how to word a determinant.
Yeah. I maybe leave you with that in this particular instance. Otherwise, I'd love to go into that rabbit hole, but I have to run to another appointment.
Okay, go. Okay.
Yeah, you could also just post this whole discussion because you're still recording.
Aha.
Oh, great.
Yeah.
Okay.
Yeah.
Okay.
I'm getting a different answer I wanted to see if you saw anything glaring here. I'm getting a different answer when I do the system of equations versus the matrix.
Yeah, well, I don't see anything glaring. It would take me a little bit to find. It's probably a negative somewhere.
Okay. All right. Maybe I'll fiddle with it.
Okay. Okay, so watch the determinant.
When you posted that last 15 minutes for the pulley video, and I
That's
had
not
to
a
sit
big-
through myself being such a effusive goober.
That's all right. No problem. You're just curious. Okay, for help, watch Tuesdays for help understanding what a determinant is.
Yeah.
Watch from 11:10 a.m. on. I'm spelling it wrong. Determinant. Okay, for help understanding what a determinant is, watch Tuesday's Zoom recording from then and on. Okay, great. I think we got it cleared up now.
Cool. I hope so.
Okay, good. Everybody good?
Yeah, we good.
Okay, Tony, any questions?
Nope, just here to soak it all up.
Okay, great. All right, thank you. All right, hopefully see you at 1 or Thursday.
Well, for me, it'll be Thursday. Yeah.
Thursday. Okay, great.
Okay, doke.
Okay, bye.
Bye.